In the previous video, we discussed the very basics of digital ledger technologies and what those are. We talked about the fact that they are distributed. We talked about the fact that they exist only digitally. And then we talked about what a ledger is, which is basically just a transaction report of all the transactions that happened in a certain time frame. The very basics of the crypto industry is something called the blockchain. The blockchain is a specific type of digital distributed ledger technology that stores transaction information in blocks that are connected together to make a ledger. So a blockchain is a type of distributed ledger technology. And we're going to be talking about what blockchains really are and how cryptos use them in order to operate. So the most famous blockchain is Bitcoin. Bitcoin is the most dominant blockchain. It's the most decentralized, and it's the one that came first. And so some people say that Bitcoin can't exist without blockchains, but arguably, guys, blockchain cannot exist without Bitcoin because of the way that the Bitcoin network is set up. So let's talk about the very basics of blockchains, and we're going to help you understand what a block actually is, what blockchains actually are, and what they're meant to do. This is not meant to be a technical video. This is not meant to go too deep into the technology, but it's very important for you to have a superficial understanding of how this stuff works, because if you're going to be investing your hard-earned money into it, if you're going to be waiting patiently for prices to move, you really should understand what's happening in the background and how this all works. So let's dive right into it. Why do we have blockchains? Why do they exist? And what is their main purpose? So in 1991, the first version of a blockchain was presented by some computer scientists. And the whole reason that they wanted to create this was something called time stamping. What you could do with this technology is you could timestamp a transaction and make sure that it can't be changed in the future. So before this technology existed, if your transaction history existed on a database somewhere, let's say in a bank computer, and the bank really wanted to change the transaction history, like it actually wanted to change what happened in the past, they could. They could go on to the back end under the administrator function, and they could change whatever information they wanted. And so if you actually went to your bank and say, hey, I'd like to prove that I bought this thing last week, there would really be no way for you to be sure, because if they change the transaction history, you wouldn't be sure. What timestamping does is it essentially puts a date and a timestamp on every transaction, and it's branded there. So you can't change, you can't go back and edit any of that information. So all the transactions that happen are verifiable, and you know when they occurred. And so the basic reason for a blockchain is a way to store this information in a way that's, time-stamped chronologically. So you know that these transactions happened before these ones, and you can actually look at the exact time and day that they occurred. So let's talk about the anatomy of a block, and we're going to talk about a Bitcoin block first, because it's the most important, and we feel like if you understand how a Bitcoin block works, it makes the rest of this very, very understandable. So we just talked about a block being nothing more than transaction data inside of this digital space. So this digital block contains 10 minutes worth of transaction history from the Bitcoin blockchain. So me, you, and some friends, we all go and start buying some Bitcoin, okay? And we do that for 10 minutes. I buy some, you buy some, our friend buys some, and our other friend buys some. At the end of those 10 minutes, we can go back and look at the transaction history and say who bought what when. It's not going to have our names there, but it's going to say this account bought it at 11:59, this account bought it at 12:01, this account bought it at 12:03, and it's going to show us a timestamp of how that played out. That individual block contains 3 pieces of key information. The first one is that transaction data that we just talked about. It shows you who bought it, where it's going, and how much is there. The next key piece of information that's included in every block is something called a hash. And a hash is like a digital fingerprint that's unique to that block. The hash is how you can actually tell which block is which. It basically acts like a fingerprint. It's your unique identifier to say this block number 5 is indeed block number 5. So a hash is like the digital fingerprint. That's a unique identifier. The third piece of information that's inside of every block is the hash of the previous block. So the digital fingerprint, that unique identifier from the block that came before, is also inside of this new block so that we can tell which order it's supposed to go in. And let's talk about that in a little bit more detail. So let's imagine that this is a chain of blocks. And to make this easier, this block number 1 is going to be something we call the Genesis block, which is the first block that ever existed in crypto. The first block that ever existed in Bitcoin specifically. So every block we just talked about has that hash and the hash of the previous block. So let's consider this the hash of this current block. It's 1F9Z. That's the password. That's the unique identifier that says that block number one is indeed block number one. Because this is the first block, there's nothing before it. And so the previous hash is 0. Now, let's say that we do this transaction, and then there's a second block that gets added to the chain. The second block will have its own unique fingerprint. And so this new block is 2zk7. But it also includes the previous block's hash, which is that 1f9z, 1f9z. And so what happens is when we look at block number 2 and we say, what is block number 2? And the computers do all this in the background. The nodes in the network do this in the background, but this is how they're doing it. They'll basically look at block number 2 and look at the unique identifier, but then they'll look at the previous hash. If the previous hash matches with a block and it's valid, then they'll add it to the next block. It'll be added to the chain as a part of the blockchain. Same thing. We have another 10 minutes of transactions. They get added right here. It has its unique hash, but it also has the hash of the previous, which is that 2zk7. All right. And that's basically how the blockchain works. It's every block has just transaction data for 10 minutes, but it also has a unique identifier and that unique identifier of the block that came before. These blocks get chained together. And the way that the system chains them together is by looking at that unique fingerprint and matching them up in a chronological order. So blocks basically have two kinds of information. There's info that the miners need in order to complete the transaction. And then there's transaction history that just shows all of the things that happened with Bitcoin transactions in that 10 minutes. So the way I like to think about it is the proof of work data for the miners, that's like the unique fingerprint, the block header, which basically shows what the block is, and the metadata. The metadata is just a fancy word to say all the extra data that shows when the block happened, how it happened, and to where and when it was sent. The transaction history is the second part of this block, and it basically just shows all the transaction data for the past 10 minutes. So Sally bought this much Bitcoin, this account bought this much Bitcoin, this account sold some Bitcoin, and this account mined some Bitcoin. So it'll show the transaction history. So the last thing that we're going to talk about is blockchain security. So what makes a blockchain more secure than the traditional system? Why are we using it? And why are there so many technologies, coins, and tokens that are being built using blockchain technologies? Well, the security of blockchain comes from three main things. And I'm going to try to make these as simple as possible. So try to follow along here. Number one is hashing. That is something that we've just talked about a few times, which is that unique signature. It tells you that this block is this block. And when it goes in the chain, we don't have to guess that it's in the right place. Number two is something called distribution of proof, which means that, and we're going to talk about this in a later video in the next one when we talk about how the transactions actually work. But the distribution of proof means that there's individuals all around the world with computers that can validate these transactions. And so it's not that your transaction goes to one place, one central authority, and they make the decision whether you're right or wrong. Because that's what happens with a bank. If you go to the bank and say, hey, that's my money, and they say no, it's going to be very hard for you to prove otherwise. The distribution of proof means, let's say there's thousands of miners around the world, all of their computers have to agree that your transaction is valid before it's added to the chain. So this distribution of proof makes it so that one group can't act against the rest of the people, and that you can't have central authority making decisions, and it's just a lot safer when it's distributed. Last but not least is something called proof of work. Proof of work is something we've touched on before, but we'll touch on it again. It's essentially where you're trading power in order to get currency. And what you'll do is you will basically run a computer. Your computer will solve complex math problems. If you solve those problems correctly, you get rewarded with a coin. And because you get rewarded with the coin, it's time-stamped to say, Sally Joe put in this much electricity to get this coin. So there's a proof there that you yourself actually earned this coin because you solved all these math problems. And the only way you solve the math problems is by running the computer that's able to do it. So this proof of work system is not like, hey, I trust these people to keep this thing going. It's really about there is actual proof that I own this thing. And the proof comes from the fact that I had to put in energy in order to get it. Now, I know that some of this stuff is a little bit confusing, guys, but understanding the basic technology that underpins Bitcoin, that underpins Ethereum, that underpins these other currencies is really important, especially if you're investing in this space. So if we can just do a quick recap together, a blockchain is just a digital ledger technology or a distributed ledger technology, which stores transaction information. It's basically a glorified Excel sheet that stores all this information in a much more efficient way. It stores the information in blocks. Okay, these blocks have transaction data for every 10 minutes. And all these blocks get connected together to make something called a ledger or a blockchain. The reason that blockchains exist is because we were trying to find a way to timestamp transactions because we couldn't trust the system to make sure that our transactions are valid. And so we had to make sure that you couldn't go back and change any of the history. Every block has 3 pieces of key data. There's the transaction history in the past 10 minutes, the hash, which is the fingerprint or the unique identifier, and then there's the hash of the previous block. And just a reminder, each Bitcoin block contains 10 minutes worth of transaction data. Here's how a blockchain looks. Every blockchain has its own hash plus the hash of the previous block, so it knows which order to go in. And the security comes from 3 things. It comes from the hashing ability, where you can have unique fingerprints for each block. There's a distribution of proof, where no one central authority can change the rules. And then proof of work, which doesn't rely on trust. It's basically just if you do the work, the system will verify that you did the work and you will be rewarded accordingly. So that's the very basics of how a blockchain works. You guys do not need to become technical experts, but I do hope that you guys can take something away and have a more informed understanding of how this space works after this video.